Hello, I'm Miguel Miller, a forecaster here at the National Weather Service in San Diego, and I have the pleasure of interviewing Joe Dandrea, another forecaster here at San Diego. He is our hydrology program manager here in our office. And hydrology has everything to do with the rain as it comes down and how it interacts with the surface of the earth. So he deals a lot with rainfall, rain gauges, and any of the flooding or debris flow issues that come up from that. So good afternoon, Joe. How are you?
Hi, Miguel. Good to see you again.
Joe and I have been working together for 15, I don't know, since late 98 when I came. Joe was here and he hadn't been here too long, so we've been working with each other for a really long time. So first of all, Joe, what can you describe for us what the hydrology program is in the overall National Weather Service scheme of things?
Well, as you mentioned, hydrology is what does the water do after it falls out of the sky? Where does it move, and how fast does it move, and the problems it may cause. And so every office does have either a hydrology focal point or a service hydrologist. Those areas that have running main stem rivers and numerous rivers have a service hydrologist, and then the areas that are more desert, like our particular forecast area, would have a focal point which works with a service hydrologist in a neighboring office, and that's our situation here.
Okay, yeah, we have Jamie Labor. He's our service hydrologist up in the Oxnard office, which covers Los Angeles. And so we kind of have to share him here in San Diego. But so Joe takes care of things for San Diego. So what are some of the developments that you've seen in your, what have you been doing this for like 15 years now or so, haven't you?
Yeah, I think it's
15 or 16?
yeah, at least that.
Where have we come since then?
When I first arrived, I mean, we actually did have the alert gauge. The alert system is a radio telemetered rain gauges that are scattered around remote areas so that we can monitor rainfall more efficiently. We did have that. As a matter of fact, it was in its infancy at that time, and since then has expanded rapidly across the area. And we have now a whole new paradigm of technology that'll take over the transmission of those signals. As it was, that a lot of times they would end up stepping on each other if we get too many gauges trying to go through the same repeater and trying to send it through the airwaves. But as technology is improving, we're going to completely revamp that, and Alert 2 will bring a lot more pathways and better data assimilation for us so that we can hopefully monitor the rainfall activity a little bit better.
So the alert rain gauge network has really developed quite a lot during this time.
It's developed a lot, and so has radar, as a matter of fact. I mean, when I first came here, we had radar. We did have radar estimates of rainfall, but the new Doppler radar and then subsequent improvements have resulted in better rainfall estimates by radar, and the radar will fill the gaps in between where we don't have gauges, where the radar can see fairly well. Now, we have some issues with that here in San Diego County because of mountains, blockage, and so forth. But it has come a long way in my career and will continue to advance. One of the biggest advances we saw it's called FFMP, which takes radar estimated rainfall over each small basin in our area and estimates rainfall in that basin. And therefore, if you have a flash flood guidance for the basin, you know about how much rain it'll cause before it'll start running off and causing problems. You can actually, FFMP can actually alert you when too much rain has fallen in a particular basin. So it's fairly automated, and it does still need a forecaster for interpretation. But that, I think, is one of the huge improvements that we've seen since I've been here.
Yeah, I've noticed an improvement since we've got the new technology in the Doppler radar called dual polarization. Mm-hmm. And you're referring to that, aren't you, as far as the way that the radar can estimate precipitation more accurately than it used to. Mm-hmm. Believe me. Yeah. Okay, so as a forecaster, I've been noticing some of those improvements there that have come from your work of being able to implement some of the newer rain gauges, the newer data coming in, and also some programs that we run here in the office to monitor that rainfall and to determine whether it's meeting or exceeding our flash flood guidance. So there's a science behind us being able to issue a flash flood warning or not, and um, we can use the rain gauge data, which is the actual report, and we can also use the radar estimation, which has gotten a lot better in order to come together. Because those thunderstorms in the summer don't often hit rain gauges, to be honest, and so we're kind of left to um, depend on the radar a little more heavily at that point.
We also, Miguel, as you know, working with the USGS, the United States Geological Survey, in their study of debris flows. And that has all come about since I started here as well. When we started noticing the burn areas and rain on those burn areas was much more, or the earth was much more unstable in those areas, and we get debris flows and large debris flows that would cause all kinds of trouble and even potentially hurt people and trap cars. And so the USGS, we've been working with the USGS to understand at what level of rainfall do these debris flows are these debris flows initiated, and once we understand that, and they also understand the volume that can be produced in terms of debris, we have a better idea of when to warn and when not to warn. And so I think we've come quite a ways over the last few years in understanding that, and it's an ongoing process.
Yeah, it's since those fires of 2003 and then again in 2007 and all the little smaller firestorms in between, we've been able to have a good kind of a proving ground of being able to determine when this happens. So yeah, that's good. And the USGS are actually the people that are going out and surveying the actual debris flows, of course, after they happen,
Right.
and determining, okay, what caused this to all come down the mountain.
Yeah, and Southern California has been at the forefront of this type of study, and Jamie Labor too is very involved in that up in the Oxnard office, our service hydrologist.
Yeah. Okay. Well, that's good because that is becoming kind of a growing problem. It seems like with the greater fire and the burn scars that we have. What would you say is one of the more enjoyable parts of the work you do, or what gets you the most excited about your work?
That's a good question, Miguel, because hydrology involves just a lot of mundane and boring number crunching and data assimilation, because it does require a lot of that on a continuing basis. Mm-hmm. But so if I can get out of the office and on an initiative where we're trying to understand how to serve the public better, that probably is the most exciting thing for me. We get out of the office. For instance, this year we got out and looked at the Tijuana River area, and some of the places that might be flooded should we start to receive large amounts of rainfall down there once again. And also working with the county flood controls and to try to gauge some of the rivers. Since I have started here, initially we only had one official river forecast point. An official river forecast point was the San Diego River. And when I say official forecast point, it's because the California and Nevada River Forecast Center actually models the river and makes a forecast, whether or not it, mm-hmm. and then also it has a flood stage or where it can exceed, and then we would issue a flood warning. So we only had one point at Fashion Valley when I first started. Now we have 4 rivers with forecast points on them, including the Mojave up in San Bernardino County, and 2 more in San Diego County, the San Luis Rey River and the Santa Margarita River. And then, of course, with the San Diego River. We also, because we have a lot of our streams and rivers are ephemeral, most of the years, and even some years, they don't have any flow in them at all. Mm-hmm. So it's particularly challenging to provide a service to somebody when you to try to put a gauge somewhere where it hardly ever works, because
it's
usually
just dormant there.
something happens along the way, and when it's supposed to work, it doesn't work. So it's a real challenge here. But we have set up with, for instance, the Coachella Valley Stormwater Channel, where we can issue at least an advisory through the River Forecast Center. We set up some simulation points, they're called. So it's not really a forecast point, but some simulation points in the Coachella Valley that indicate when flow will occur through that stormwater channel, and it overflows roads and causes all kinds of havoc through the Coachella Valley.
Yeah, you're talking about the Whitewater River
right
bottom there.
It is essentially the Whitewater River, but they refer to it as the Coachella Stormwater Channel because it basically, on that part of the channel, only has water in it when there's a storm and there's excess flow coming down off the San Bernardino Mountains.
Right.
So we were involved in that, and even now we're still trying to get a few more gauges out there on the Mojave River, which is kind of exciting, because when it does flow, it's pretty dramatic. But again, it's that where it only happens once every few years, which makes it really difficult for us.
Well, like fire departments or like the hurricane center, most of the time you're just preparing.
Exactly.
And that's how it works. So you mentioned some partners, the county flood control departments you work with and you can maintain relationships with.
Yes, all the counties have flood control agencies that we stay in contact with on a daily basis, and a lot of them have their alert gauges. They're not our alert gauges; they're their alert gauges, but they feed their information to us so that we can use it to issue warnings. Also, we mentioned the U.S. Geological Survey, and then the Army Corps of Engineers, which are the dam regulators, the dam builders. And reservoir regulation and so forth. The River Forecast Center is very involved in that. Us to a lesser degree, but we do have the contacts down here with the Army Corps of Engineers as well. And then there's the local fire stations and emergency personnel as well.
Right. That's a lot of people to talk with and keep a relationship with.
Well, it isn't just me. Our Alex Tardy, our warning coordination meteorologist, is very, very involved in a lot of this as well. So,
well, that's good. Is there a watershed moment or a memory that you can remember that where you got to see your work come to fruition, I guess is the word?
Well, I think the one thing that comes to mind is I received the Administrator's Award, or the NOAA Administrator's Award, for my work with the debris flow program. And even though, again, this wasn't mine solely, to be sure, there was a group of us that were involved in it, but it was very exciting to be able to fly to headquarters out in Washington, D.C., actually receive an award in recognition for a lot of the work that had been done over the years with that.
And practically speaking, I can vouch for the improvements with all of the flash flood guidance that comes with the debris, that came from the debris flow project that has made my job a little bit easier when it comes to rain falling on those burn scars. So
right.
Well, Joe, I appreciate your time today. It's been illuminating even for me that's worked with you so long and doing that, and hopefully for those who listen and read. Thanks very much for your time.
Oh, you're welcome. Thank you.